Yeah, Dr. Anil, are you?
Yeah. Hello.
Yeah, okay, welcome.
Thank you.
Yeah, so my chairman, Mr. Vivek, will give you.
Good evening, sir.
Very good evening, sir. Very good evening.
Good evening. Now we are joined by our ex-honorary chairman, Mr. Sidney Punaya, and Mr. K.S. Kamath, our executive committee member, Mr. Ramit, and Arvind Gupta, you know him.
Yeah. So, some others will also join us, sir?
Oh, yes.
Yeah. They will join in between.
Join us.
Okay. So, shall we start now?
Yeah.
Yes.
Or shall we be?
Sure. Yeah, sure.
Okay. So, so my talk is on basically the solar energy implementation on the process industry. So now, I would like to discuss the industrial energy consumption statistics for the few countries only, 10 or 9 collect solar collector and their temperature range, and based on that we can decide on which kind of the application, industrial application, it can be suited. Then the heat requirement for the industrial application on various process. Then now just this figure, voice is coming, no, sir?
Yeah.
Industrial consumption. Yeah. Industrial consumption.
So everyone can go to mute so that the speaker can be active.
As we know, the energy is a fundamental input and an essential need for the advancement, modernization, economic evaluation of any nation. As we want the development based means the industrial development basically. Industrial development means the more energy consumption. More energy consumption means right now almost 80% our dependency on the fossil fuel itself, right? So directly the carbon emission will be there. So that is the major serious problem. So IPCC has framed some rule for the developed country. They're different for these. So now, that is more challenging basically and that carbon emission we can reduce either by the by reducing the energy consumption. By reducing energy consumption means enhance the efficiency of the overall system, and another way is by implementing the renewable energy sources. Okay, so this figure shows you the 10 country statistics: the Bangladesh, Brazil, China, Germany, India, Malaysia, Norway, Pakistan, Turkey, and US. So this is basically the industrial energy consumption. So industrial energy consumption in this among these 10 countries, Germany has the lowest at 28%, and China has 70%. But obviously, we as everybody knows the China's progress in the industrial sector, and on an average, basically, the global average value is 35%. So 35% of their entire energy consumption of that particular country. So this is the 35%. So, and in fact, if we see the global level, global energy consumption, almost the 30 to 35% of entire global energy consumed is the industrial sector. So these all depends because of our modernization basically. And so out of that 35% industrial energy consumption, just to see over here, the 30% of the industrial heat energy consumption is under the 150 degrees centigrade, 150 degrees centigrade, right? And 22 is the intermediate between the 150 to 400 degrees centigrade. And these up to the 400 degrees centigrade temperature, whether it is the hot air or the hot steam, that we can easily achieve with the help of the solar energy, right? So remaining 48% at the high temperature, more than the 400 degrees centigrade, that is also achievable with the help of the solar energy. And heliostat type of the collectors are there. Even you can achieve the temperature of the 2000 degrees centigrade. So by that way, this solar energy we can help us to reduce the carbon emission as well as our dependency on the fossil fuel, right? So, okay. So there are many sectors for the developing country or any developed country: the agriculture, textile, pharmaceutical, food processing, brick, cement, textile, and these are the major sectors. And the process involved in all these sectors: the drying, dyeing, boiling, washing, and sterilization, pasteurization in dairy industry. So these are some process, and none of the process is required the temperature beyond the 150 degrees centigrade. And 150 degrees centigrade we can achieve very easily with the help of the solar thermal energy conversion devices, right? So energy consumption in the steel, glass, and ceramic industry is around the 13% of the industrial process and implementation, because a lot of heat is required in these type of the industry. Low temperature thermal up to the 100 degrees centigrade, whereas this right. So our aim is the eco-efficiency approach is to be adopted to restrain the emission and overcome this challenge. The IPCC, because of the IPCC, has given a lot of, so about the 1/3 of the energy total emission is released by the industrial sector. Almost 37% of the global emission is because of the industrial sector only. So emission raised by the 1.5% each year from the 1972 to 2004. So basically, in all, the solution is only the renewable energy, sustainable solution for the survival of humankind. Okay, so this is the layout, basically how the solar energy can be implemented, like in that way. This solar collector can be any type. I will in my coming slide I will just show you. I will show different type of solar collector. So solar energy is coming. Solar energy means the solar radiation, shortwave radiations are coming from the sun, and some kind of the device is there, solar collector, that converts the solar radiation, short wave radiations or electromagnetic radiations into the heat, and basically that heat is transferred to the heat transfer fluid, and there can be the air or the water or some other kind of the heat transfer fluid also here can be there for the high temperature applications. And in fact, this storage tank, this is where this makes this more reliable solar energy, because as we know, the solar energy is the intermittent source of energy, right? So that solar radiations we are receiving during the daytime but not in the night time. So by introducing the solar that storage device or some kind of the storage system, introduction of this, we can avoid the such kind of this intermittent problem of the solar energy we can avoid, right? So and the boiler and furnace, these are the two devices are responsible for the most of the energy consumptions, fossil fuel consumption. So that some auxiliary type of unit we can, I agreed that totally we cannot replace completely with solar energy with the fossil fuel consumption. Okay, so this so here that captured solar energy or the solar energy converted into the heat that can be run for the heat engine and many kind of the heat engines based on the organic fluid, so that the mechanical energy can be converted into the electrical energy. That is one route. Another route is the direct heat application you can use for the industrial process heat purpose, right? So yeah, so basically the main thing is solar collector, solar storage system, working fluid and capacity of system, and load factor and location of that specific application. And location means if you want to implement, or if you want to install that solar energy conversion device, you need to know what is the solar radiation around the year. That assessment or that solar radiation assessment is very necessary, annual assessment basically, before the design of, before installation of any system, right? So now just see over here, there are many industry: dairy, tin food, paper, textile, chemical, meat, beverage, flour and byproduct, timber product, brick, plastic, and in fact one more very important industry, the cement industry is left over there, but I have that case study. I will show you in my detailed later slide. So some processes are there: pressurization, sterilization, drying, concentration in the dairy industry, sterilization, pasteurization, cooking, drying, bleaching, drying, and these all, most of these processes are governed within the 200 degrees centigrade. So synthetic rubber processing in the meat, washing, sterilizing, cooking, washing, sterilizing, pasteurization, and again the beverage, the timber product, okay, timber diffusion, beam, drying food in food industry, in the drying, and almost all the crops, they are drying crops, fruits or crop, they are drying not more than the 70 degree temperature, and generally they're drying between the 50 to 70, or at most not more than the 70 to 75 degrees centigrade. Otherwise the nutrient value will be lost because of the high temperature, and sometimes the germination also lost, right? So just I want to say these are the major process happens in the different industries, and we can easily implement the solar energy by replace the fossil fuel consumption over there, right? Yeah, solar energy can be converted into the direct electrical energy if we need, but in this talk our concentration is basically based on the thermal energy application of the industry process heat. And the hybrid collectors, these are very now these days, the hybrid collector, photovoltaic PVT system and concentrated photovoltaic system, these are very much useful in the condition like the Leh Ladakh and European country. With the help of this, you can get the thermal energy as well as the electrical energy. And in fact, with the implementation of this, the combining the system, both the system, you will not believe the efficiency, the overall efficiency of the system is reached up to the 75%. And it is really very much high for any solar energy conversion device. None of the system, whether it is solar thermal or this solar photovoltaic solar cells, they cannot achieve the overall efficiencies up to the 70%, 60%. No, it is not possible. But the combined way, it is very much easily possible. So now, solar thermal collectors, then we can classify the solar the concentrating collector and non-concentrating collector, flat plate, compound, evacuated. These are the concentrating, non-concentrating collector. Non-concentrating collector means the concentration ratio is 1, basically. Means the absorber surface area and the reflecting surface area, both are equal. But in case of the concentrating surface, it can be up to 5 to 15. This concentration ratio, and it can be very high for the central receiver or the heliostatic field type, this thing, or the power generation. So parabolic trough, linear fractional type, parabolic dish, central receiver. So this in this way we can classify these collectors, right? And in fact, concentrating collector have the specialty like high thermal efficiency they can achieve, but on the other hand, it cannot work on the diffuse radiation, because the solar radiation has the two components. One is the global radiation, direct radiations, and another one is diffuse radiation. And the specialty of this flat plate collector, through which we judge most of the domestic application. This is applied for the most of the domestic water heating system, flat plate collector. And now these the evacuated tube also. So that flat plate collector, we can achieve the temperature of the water up to the temperature of 80 degrees centigrade. And if you require more than 80 degrees centigrade, then the evacuated tube or this kind of collector. So and very cost effective basically. And these collectors are work basically on the diffuse radiation also. Even the cloudy weather, this can work. But on the other hand, this concentrating collector, they cannot work on the cloudy weather. So this is another problem with the concentrating collector is the reflecting surface that degrade with the time, right? So now some pictures are over here, like the flat plate collector, compound parabolic collector, the These both are compound. Then evacuated heat collector, this solar the heat loss can be reduced over there. It is more efficient as compared to the flat plate collector, evacuated tube collector. All right, the parabolic trough collector, linear fractional collector, then the parabolic disc reflector. This parabolic disc reflector, the Stirling type engines are being run with the help of this kind of device. The heliostatic field reflector, this is for the power generation basically. So here, the temperature of this over here at the top, the boiler, that it can be reached up to the in the range of the 700 degree temperature. Right? So now, overall typical feature for the flat plate, compound, parabolic, and evacuated type collector. This flat concentration ratio I have already discussed when the area, absorbing area and the reflecting area are the same. And basically it is a ratio of the absorbing area to the, this meeting has been updated by, okay, slide. So temperature range for the flat plate collector up to the 80%, 80 degrees centigrade, and the evacuated type up to the 200 degrees centigrade, and compound parabolic concentrated type up to the 40 degrees centigrade. So this much of high temperature we can achieve with the help of a simple kind of the temperature, simple kind of this. If suppose the solar thermal energy integration is there, these three kind of the conversion device, solar thermal conversion devices, very much sufficient for any kind of the industry. If suppose we need the very high temperature for the steam production and all, yes, of course, the other kind of this PTC, parabolic trough collector, linear fractional collector, and this parabolic disc type collector and heliostatic collector. Just to see, the concentration ratio is more than in 1500 degrees, 100 to 1500 that range, and up to the 2000 degrees temperature we can achieve. And this kind of temperature is very much suitable for the power production and cement industry, right? Yeah. So yeah. So this is a solar thermal collector integration with the existing heat supply, boiler, process heat. As per the requirement of process 1, process 2, process 3, as per our requirement, we can trap the heat at that temperature level and return it again. And it can again integrate with the storage unit also. So solar thermal collector integration, that can be a solar energy system, heat demand, the solar water heating, district heating, cooling, solar refrigeration, solar desalination, and the solar heat in industrial process. That in that way we can integrate it. Now just see over here the different collector with their application, the different industry, right? So water heating, for the water heating, solar water heating, the integrated collector, passive and active. Basically passive active difference is that if we suppose apply some external device to create the for the forcefully we are means the rate of flow is we want to increase as per our desire. Some pump is introduced, that that means that the system is known as active type system. If suppose the system is working based on the thermosiphon effect, it is the passive type system, right? So integrated collector, passive, flat plate collector, ETC, and just these like direct circulation, indirect air heating. So flat plate, ETC, and CPC kind of this are sufficient for the water heating. District heating and the cooling system for the collector, again the FPC, ETC, and these are very much sufficient, right? And again for the refrigeration, these three kind of the collectors are very much sufficient. Absorption type unit, solar refrigeration system based on the absorption or even the adsorption type. Then the solar desalination, solar still is very single slope solar still, double slope solar still, and if that is in per unit surface area, it gives you around the 3 liter of water in 24 hours. So although that yield is not much enough for a family, but that can be enhanced with the help of some other techniques like the spray assisted system and some other the multi flash type and vapor compression. And in fact, the solar desalination and the solar refrigeration, that we can couple to make it more energy efficient. And the solar heat in the industrial process is collector type like the FVC, evacuated type, compounding type, linear fractional type, and parabolic tuff type collector. So in that case, natural convection will not is not sufficient. We need the active and some force circulation must be there, right? So
can you
yeah.
call her because I am on the technical meeting.
Okay, so this. So for the industrial heat demand by the temperature range, the solar process heat application, just look at this slide. The dairy in the pasteurization, sterilization, drying, and concentration. The maximum temperature for the drying the 180 degrees centigrade, and that is easily achieved with the help of ETC, either ETC or the CPC type, right? So, and the tin food, again the maximum temperature is attainable is needed is there, the 120 degrees centigrade. Paper industry 150 degrees centigrade. Textile industry rarely, fixing is there. Okay, one in textile, 180 degrees is there. Otherwise, most of the application is less than 100 degrees centigrade. The chemical, soap, synthetic processing, heat, preheating, or less than 200 degrees centigrade. Beverage 60 to 70 degree. Pasteurization 60 70 degree. Again, the flour and the byproduct 60 80 degree. Timber and all. Just a brick, of course, in brick the 120. Okay, curing in 140 degree. Oil refinery in plastic and all of not more than the 200 to 20 degrees centigrade over there. So yeah, if suppose the axis, single axis, double axis, two axis tracking is there, of course that is more efficient. Now just come to the simple solar thermal energy storage system. As I have already told you, like if we integrate the storage device in the system, it make it more economic feasible, of course, and as well as it is more feasible and reliable. Solar conversion energy system is more reliable if we integrate this storage device, right? So this hybrid solar collector and the fossil fuel system we can integrate, of course, because we cannot replace completely. Okay, so some in the form of the auxiliary system, that boiler and the thermal energy storage in between the solar collector, then network, and again the solar thermal energy storage system method for storage, the active, direct, indirect, passive, and the temperature range, the low temperature, medium temperature, and high temperature. That again depends on the material. So sensible heat storage, some that basically that is the that we can decide based on our requirement. What range of the temperature is required. So sensible heat, latent heat, and the thermochemical heat storage material. Again, the liquid, solid, organic storage. And those heat storage system we can decide. So cost, so economics is again a very important factor. So cost of the different type of solar collector, like in India, this is 180 USD per meter square collector area. Compound parabolic collector is 333, and China 130, and in fact and most of the thermal energy conversion device are importing in India from China itself. So parabolic disk type 113 to 300 USD parabolic. So parabolic trough in India, Europe, Mexico, Europe, and all. Linear fractional type collector in costly one. So it requires less area as compared to flat collector for the same heat output. And just see over here the annual CO2 emission saving from the different industrial sector. The dairy sector, we can easily save the 32 to 144 thousands tons of the CO2 equivalent. That much of the huge amount of CO2 we can save by implementation of the solar energy. solar energy conversion device. The paper industry, again, the 350, 340. Textile. So huge amount of energy means CO2 emission we can save with the help of by implementing. So now just because my talk is related to drying, and drying is in fact is the part of the most of the industry, and in fact I will discuss in detail the textile and the cement production over here. So far the drying is taking place in the most of the industry is taking with the help of the electricity, fossil fuel, natural gas, wood, bark, or rarely solar, right? These are the sources. And already told depletion of nature, depleting nature of the natural fuel resource, rising fossil fuel costs, environmental degradation. These are some problems. And solar energy intermittent problem I have already through hybrid drying system. Okay, now. So in the drying, the industrial drying, this is for this slide for the UK basically. In the UK, the industrial drying consumes significant portion of the total oil manufacturing process, which is 12% of on an average. So 12% is still more. For instance, the drying industry was estimated 128 into 10 to the power megajoule per year in selected UK area. The C over here, and again, so that I have already discussed basically drying. Okay, percentage due to drying. Okay. So just you see over here the amount of energy consumed based on the drying only. So food and agriculture, 12% of the total energy consumption in that industry is basically the 12% share is goes for the drying process. In chemicals, 6%, textile 5%, paper 33%, and this is true for only the UK industry. And of course, we can assume the UK has the most advanced process or the most advanced technology in all kind of this industry. Though they have very less industry, but whatever they have, but we can assume they have the latest advanced technology. So even though the 12% of the total energy consumption is share is for the drying, 6, and just see over here the 33 for the paper, 33% of the energy consumption in the paper industry is goes for the drying process itself, and drying takes place less than 100 degrees centigrade. So that energy consumption we can easily replace with the help of the solar energy conversion device. Ceramic, building materials, the 11%, and like in that way. So on an average, the 12% is over there, right? So in textile industry, you see over here, the drying is energy. These are different process and continuous. Yeah, dyeing. Mainly the two processes, the dyeing and the drying. So just see over here the 7.5 gigajoule per ton of the output. This was the huge consumption of the drying and drying industry. Even the 20 gigajoule per ton of the output in textile industry. Okay, so breakdown of the solar thermal energy used in the dyeing plant in the Japan. This is for the Japan. They definitely they have advanced technology. Now these slides are very recent. These are not the old data. So the product drying, the share of the total thermal energy in terms of percentage is 17%. Just see the product drying 17% in textile. This is for the textile. Yeah, in textile industry, right? The waste was just see over here, almost 17.2% product for the drying purpose only. Okay, in textile industry. So now, so solar energy can practically utilize the textile industry where the low temperature are needed for the textile process. Heat can be efficiently used in drying the textile, two processes that need a large amount of heat. And the hot water is not more than the 80%, 80 degrees centigrade. And that basically easily we can get from the solar energy. Drying process needs a steam to dry the wet textile. In this process, the textile is passed over the hot surface of the cylinder and steam is boiler heated in there. This is the process. So first category and second category. I will show you over here. Just see, this is the preheating. This is the first category over here with the help of solar collector, storage tank, pump, and boiler, and that can directly taken from the here. And if suppose only the dyeing process, we need this kind of the circuit can be there. In the preheat, the part load in the dyeing, which is about 50% of total steam is returned to boiler, while to steam total steam generated 20 tons per hour during the 10 hour. On the other side, the contaminated water that is used in the drying process cannot be reused. This is the second drying solar system. This is the drawback basically. So the collector area we can optimize with respect to the life cycle saving and the solar fraction also. So just see over here. Here the maximum this is reaching over here somewhere. This in the first diagram, the solar fraction. Let me define first the solar fraction, because the system output energy and the total load, that is the solar fraction. This much of load we can shift towards the solar energy. The system efficiency, the output, and over. This is general term. So now just see the collector. Another problem is you need to have this collector installation area, and now these days most of the roofs are already occupied with the many machineries, many systems over there. So that is that we need to optimize basically. So based on our requirement. So okay. So over here, almost the 1600 area collector area is over there for the life cycle optimum, the solar fraction, right? So similarly over here, this figure, just see over there. Okay, this is for dyeing, and this is preheating load. So in both the conditions, we can optimize the collector area. Just environmental impact of the dyeing of the solar system, Just see this small, this gray area is for solar system. Of course, the solar energy is not completely free from CO2 emission. Some emissions are there because the system fabrication, system generation itself needs some this CO2 emissions. But it is as compared to this conventional system, boiler as based on the conventional fuel, it is very less. So CO2 emission for the solar system for boiler, the waterborne emission, just see over here the emissions, SOx, NOx, CH4, and this VOC is very high in case of the boiler. But as compared to this solar system, it is very less for solar system, right? So clay brick production industry, Iran, Belgium for the energy use brick industry in some selected country, the Iran, Belgium, Germany, Denmark, and all, and the specific energy consumption and the specific electrical energy. Just see, it, of course, this industry, brick industry, is very energy intensive industry. Okay, so now just come over here. This is a cement industry. It required very process heat, very high temperature. In the range, start itself the 400 degrees centigrade and up to the 2000. So one experimental setup at the lab scale has been done, right? So the process achieved, the solar energy used in the cement industry can be achieved by the solar kiln. Kiln can be used for the simply and can be insulated with the natural air circulation. Dryer automatically improve the thermal efficiency and can use energy. On the other hand, this process and its construction are complex. In the cement industry, the require heat drying the raw material before heat the drying of the solar before putting supply the preheater and this. So here basically this feasibility producing Portland cement clinker basically. So raw material under the consultation solar, the PSA, the high concentration solar furnace SF40. This is the one kind of the solar furnace basically for creating the high temperature up to the range of the 1500 degrees centigrade or the 2000 degrees centigrade. So for this purpose, the short thermal cycle and what device of the fire, it is increased in terms of the cycle itself, right? So 900, it reached Within 5 minutes of the time, the temperature reaches the 950 and the 1250, 1300 followed, and in the next 15, within the 15 minutes, the temperature can be achieved in the range of the 1550 degrees centigrade. And this experiment basically was done in the German, one of the country in one lab. So European standard, they have Portland clinker. So material to be clinking the temperature above 600 and then fire normally at the temperature in the range of the 1500 to produce the fine powder in the clinker. Okay, so basically, just I want to say that even the cement industry itself, the solar energy is very much reliable, and this is basically lab skill level setup. The shutter and heliostatic type of collector they have put, and just I want to say over here, the SF40, the solar furnace. This is the SF40 solar furnace over there. The peak X7. This facility has the 40 kilowatt of the power, which is the peak concentration of the 700 sun. One sun is equal to 1 kilowatt per meter square, right? So just look at this table over here, and these are the this figure A is the outside figure. This is the inside figure. Concentrator, pyrometer, mirror, and some test table. Infrared camera is over there to measure the temperature range. Secondary concentrator and the sample holder, and these are complete experimental setup in the lab. So amount of sunlight incident on the concentrator, therefore the radiant interior focus on the control and regulation. It is fine. No need to be. So grade 1, grade 2, grade 3, and grade 3. So solar radiation, just see over there. Solar radiation in the range of 880 watt per meter square. This is the solar radiation. This is. Within that level, you can easily achieve 1560 degrees centigrade temperature. 830, 1570 means, I mean to say that within the 800 watt per meter square of the global radiation range, you can easily achieve the 1500 degree temperature of the temperature. Okay, so the achievable CO2 evidence rate and solar cement plant, as you see, between the 14 to 17% of CO2 we can easily avoid. The cost is 118 euro per ton. The competitive base. Okay. So implementation of control sequestration of the CO2 in the control calendar shows 40%. So these are the two kinds of system for the implementation of the solar the cement industry, solar energy. The heliostatic reactor is there, reactor at the top, and then the solar thermal storage at the bottom. And another way is that this tower reflector is there, and reactor can be keep at the bottom itself, right? So in the second kind of system, one advantage is there. If suppose a maintenance problem is there, of course it is very easy. Otherwise, people has to climb over there, and maintenance is always difficult if a person is rising on the 100 meter feet or meter height of the tower, right? But on the other hand, but in this type B kind of system, tower reflector kind of system, the additional device is tower reflector is there. Again, the cost is increased. So this approach is considerable advantage, placed on the ground where easily supplied, that I have already discussed. Yes. So these are the top tower system and beam down system. These two types of the systems are generally implemented in the cement industry. Yeah. So example of the 100 megawatt process supply solar power plant. Okay, the same thing. Solar cement power plant is the conventional cement plant. Just we are adding this our solar calcination technology over there. The same system, the bottom kind of no, this is not. Yeah, no. This is first kind of system. The clinker product, rotary cleaner, rest of the process is same. Okay, so this is one. Okay, the system. So the principle of the energy analysis, the solar DNI. So solar DNI is very important criteria. Basically, if you want to install any solar concentrated based technology, you must know the solar direct normal incident radiations. Direct normal incident. hourly basis around the year. Then allostatic field layout. You need to have the sufficient that much of surface area. Energy and operational assumptions and limitations. Some limitations are also there. So in this way, you can do the energy analysis of the whole system before installation in there, right? We can predict very well. Some software, ready-made softwares are also there. Otherwise, we can do that modeling itself. Right. Now come to this wood and timber industry. See over here again, the drying is another very important process. And where is drying? Yeah, solar timber dryer, particularly symbol is in the timber drying, the greenhouse type of dryer. Basically, solar drying are the can be classified the direct drying, indirect drying, and the mixed mode of drying. And because when we need to dry the bulk product in the bulk, right? In the bulk means, so the greenhouse type of drying systems are very good, because I have one patent also in the greenhouse type drying system, and this kind of the dryer are very means easily you can make. There is no very we do not have a very high tech. Just we have to enclose the surface, right? So material can be the glass. Glass is better. If basically we want transparent surface must be covered over there. So now, so in this industry, in the solar timber, okay. Then the dairy, one of the milk process to produce the milk powder drying is essential. The stage where the moisture content must be the reach up to 3% dry basis. Integration of the solar thermal system. Of course, this. Now just see over here. This is the complete picture of the most of the process occurred in the dairy industry. Maximum temperature is over there, like in boiler, pasteurization, economizer, cooler, water storage, the heat exchanger, and the coagulation. The maximum temperature is only just I want to show you maximum temperature is not more than the 80 degrees centigrade. 75 is the maximum temperature. 78 is there. 95 not more than the 100 degree temperature. Okay, none of the processes required the temperature more than the 100 degrees temperature, and the 200 degree temperature we can easily achieve with the help of solar conversion devices, solar energy devices, solar thermal systems basically. So now, yes, you see the how hot water demand that we can easily achieve with the help of solar water heating system. In the energy utilization of the current dairy activities, pasteurization, hot water demand is 45,000 kg per batch, 7,500 something, 16,000 something, 45,000 something boiler. But the temperature range is not more than 100 degrees centigrade. And that temperature is very easily achieved with the help of the evacuum type of collector, and it is very cost effective. So instead of burning the fossil fuel and creating the problem for the environmental degradation, we can avoid such kind of problem with the in dairy industry. And in fact, in India, the Karnal, this National Dairy Development Corporation, NDDC something in the Karnal, they have successfully implemented the solar thermal conversion devices for their most of the process. So, and just see, this is the daily overlap between the between times of the heat demand and the solar irradiation. As the sunrise, as the morning to noon, noon to evening, our demand is increased with the with rising the solar radiations. So that we can easily what is called easily incorporate. Even though we need heat storage system, some devices, but if suppose in some kind of industry the storage is not needed, then we can easily like the solar refrigeration system, not refrigeration, air conditioning. And this kind of figure is very useful.
Continue.
So shall I continue?
Yeah, please continue.
Okay. So annual overlapping between the demand energy and the solar radiation long time. This is the total radiation and the energy boiler, energy from the boiler for the dairy industry. And the proposed this kind of system we can have solar radiation conversion device, solar field over there. It could be flat plate collector, of course, will not work over there because the commercial level or the industry level. We need the PTC or the evaporated heat collector, and some storage tank is there. So in that way we can design, we can implement. Okay. So daily participation of the solar and conventional duties, like in that way the energy contribution, daily conventional contribution. See over here, and the sewage industry also. Solar thermal device can be very helpful in the solar the sewage industry for the drying, because that sludge need to dry, and sludge can be used further for the char purpose. For char making, we need to have the dewatering of that sewage, that sludge, and that we can do very easily with the help of solar dryer, especially greenhouse type, solar greenhouse dryer type systems. They're very useful for the sewage drying. And the biomass fuel again. If suppose the biomass, if suppose some power plant is there, biomass based power plant is there, we need to reduce its moisture content. If moisture contents are there, that means the heat is utilized in the form of the evaporation of water. So that we can avoid with the help of biomass drying in the greenhouse itself, because it is a bulk drying that we use. So drying is a significant challenge step between pre-treatment of biomass and the second generation synthetic fuel. So in that way, that it can be helpful. Agriculture crop drying. Everybody knows that since the ancient time, we used to spread the crop over the floor on the outside. The sun is coming, that is open sun drying with the help of the solar radiation. But that process has the many drawbacks, like the quality of the product, quality of the crop, vegetable or fruit, slice. It is degraded because of the ultraviolet radiation directly coming in contact with that. And another problem is the contamination, the ferrous content, the color you might have seen or observed, the color of the open sun dried product becomes a dark. That is because if suppose the carbon content, ferrous content, the iron content is there, that ferrous oxide, because of that ferrous oxide, the color is dull color, very dark color becomes. So dyed product have the dark color. So this several method of preservation or agriculture product, increasing the economic life cycle, nutrient value, of course. If suppose it is controlled means with the help of the indirect solar dryer are there. And in fact, the solar flat plate collector in the Pune and some nearby the Pune industry. And I have also consulted one in the spice drying industry in the Indore when I was in the Bhopal for designing their drying system, for designing their collector for their requirement, and it was very much successful. They used to dry the red chili before the grinding, especially that for Indore, because in nearby Indore that red chili is very much cultivated, a huge amount. So this amount, and in fact in such kind of applications, the conventional type of greenhouse doesn't work. We need to modify the conventional drying system, conventional greenhouse drying system, or conventional greenhouse dryer. So, and you will not believe this, the payback period is less than 2 years, only 18 months at the most, very cost effective. Okay, so industrialized countries, the energy consumption of drying is between 7% to 15% total energy consumption. Just see, in the industrialized country, the energy consumption of drying is between the 7% to 15% of total energy consumption. Still, drying is, again, drying is very energy intensive process. Okay, so that we easily, yes, the Spice Board of in India, they propose the commercial drying operation can be switched over to solar drying and minimal operation. Yeah, payback period over here also. So like in that way, the total, the economic aspect of the solar drying in 2007 to in the prediction of the 2050, the energy consumption, the total non-renewable energy, the huge contribution is there. Biomass, then biofeed stock, the solar thermal is very less. So very less contribution is the economics of the solar drying, analyzed based on the analyzed cost of the dryer, annual saving, present work. So some this annual saving, present work, annual saving, like in cumulative each year during the life of the solar dryer, drying pineapple. This study has been conducted for the pineapple, the 250 days of the solar. They have considered the 250 days because in India, although the almost in most of the area, the 60 days are for the rainy season. So, but they have excluded more than that, 50 days, maybe because of the maintenance or other process, the change time consuming for the changing the batches. So, just see over here. So now, this is another, this is assessment of energy and cost and the packed weight. The heat storage based or the phase change based material thermal energy storage, the solar assisted solar drying process. So now, sensible heat and the phase change material, they have been used for the drying process. The objective of this is to compare the two systems, two storage material, physical and chemical properties completely different, right? So these are the two kind of systems. These are the some photograph of the this table based thermal energy storage systems are there. This solar radiations are coming over here by pumping. They are using this. The fresh air is coming with these directions. Okay, so energy storage media. One number is energy storage media, and the two is the pebble stone that you can see easily. This is the pebble stone. Perforated plates. These are the perforated plates over which the crops or the fruits or whatever you want to dry, that can be spread over the tray. Then fan, 4 number is, this is the fan. This is the force supply, because this is the indirect drying. Passive mode will not work over here efficiently. Then the air collector, then perforated plate, fan, filter, and all, right? So there is some photograph of the pebble based. Okay, yeah. Now this is the PCM based. Again, the same system. Instead of these pebbles, they have put the capsules, PCM based capsules. They kept over there. So basically, this kind of systems are useful for those crops which are very much very much sensitive for the time. Basically, if suppose some fruit is cut and the slice, and you cannot keep in the long hours. So in short, you have to dry very fast in the short period. So there should be the continuous drying, right? Because of that reason, the storage is being implemented over there. So these are the some system. Then the tray type of system. Okay. Again, these are the some results. You can see the temperature can be rise, and in fact the temperature inside the drying chamber, that depends on the which kind of the crop you are being you want to dry, because all the fruits, most of all fruits and crops, they are very temperature sensitive, and based on their permissible temperature limit only, we have to decide. We have to decide that kind of the PCM material is needed, and the long in the time of the drying time, like in during option sign R, you want the 8-hour more during option sign. Based on that only, you have to calculate the heat capacity and all with units, right? So these this mass flow rate. So in drying, three major parameters: the temperature, relative humidity, and the mass flow rate of this hot air. So these three parameters we have to optimize for some particular crop or some right. So these are some results of the PCM based on table based. Of course, the PCM based has a more consistent, right? And after drying process, the people dry the leaven before drying and after drying, and then these are some okay. This is change the water absorption theorems. Okay, this is the indirect solar dryer, very useful device. In fact, we have also designed this indirect solar dryer for the banana drying. Banana, basically in Thailand, the one banana is there, ladyfinger banana. They have the many cottage industry in the Pathlong province. They have huge cultivation of that ladyfinger banana. They used to dry in the indirect drying system, and and they generally those dryers are basically based on gas type. The burners are burners at the bottom. They burn the gas. Burners burns at the bottom. The hot air is supplying for the tray. So basically, there is, and they were not energy efficient. And I spent there for 2 years in the Thailand, and during that time we got some fund for. In fact, for the development of those cottage industry, we designed one indirect drying system. Basically, it was the hybrid. And gas, it was working with the gas itself, and natural gas from the market, and another, the peel, the banana peel is there. So banana peel is degraded in the anaerobic digestion. So by methane is generated with the help of the anaerobic digestion from the banana peel itself, and that gas is used for the drying purpose, right? So we replace 22% of the fuel consumptions with the help of that banana peels. So such kind, similar, not similar, some different kind of, but it was indirect. So they have three types of dryer: the indirect dryer. Of course, the indirect dryer is much useful. This is the greenhouse type drying systems, right? So greenhouse type systems can be storage based, without storage, heat storage, sensible or thermal, PCM based. Or paper has been, they have dried the paper, red paper, okay, drying time and all, many other parameters, moisture ratio. So yes, this is the mixed mode type of drying system, right? So these collectors are there, the solar heating collector. These are the two collectors, collector 1 and collector 2. Okay, so and with the help of blower, they are supplying the hot air. And hot air, this air can be the temperature in the range of the 75-degree temperature, and that is more than sufficient for this drying any kind of food inside this tray. Okay, so this is simple solar air heaters, and glass cover is over there. Means solar radiation directly coming from this side also, and this indirect. So this kind of this system are known as the mixed mode type of systems. Two kinds of the energy source are supplying over the drying chamber. So yeah, this is energy analysis has been done for the fluidized bed drying integrated, and this fluidized bed drying integrated with the biomass furnace. Just see over here, the solar collectors are over there, and biomass furnace is there. This is very fast drying, fast dryer, right? So solar assisted fluidized bed combustor is there, like in that with the solar collector. Then this is biomass furnace over here, the blower. Then this is paddy drying. Paddy is coming from this from here and out later. Very fast drying is over there, outside there and over. So such kind of systems are there based on the solar energy. So now, yeah. So now I can say the solar technology can be used for a variety of industrial applications for the sustainable energy in the industry, these should be used for the industrial application, which are more compatible for the integrated, to be integrated. And this is my forthcoming book on the energy management from the CRC Taylor Francis, Conservation and Audit. Thank you. Now, if some query is there, I would be happy if I could able to reply.
Thank you very much, Dr. Anil Kumar, for a very informative and very wide coverage of the solar energy for the industrial drying facility. So I really thank Mr. Our colleague Arvind Gupta to arrange this particular presentation. And I request if anyone of this member can ask any question if there is any.
Yes, sir. Please.
Please unmute Mr. Sidney. Please unmute.
Yes.
Thank you very much for the interesting seminar. I've been looking for this seminar for a long time.
Okay.
I saw that you have you said that solar can be used for the STP, sewage treatment plant. Is there anywhere they use for the RO plants?
RO? Reverse osmosis process. Yes, sir. Actually, that for the reverse osmosis we can do, but for the basically reverse osmosis process need electrical power. So first we have to solar energy for solar photovoltaic systems we need for that, not the solar thermal device.
So this is actually, have they done it in India? Any part? Have they done this?
Yes. It in Delhi itself, in NICE, for the demonstration purpose, they have implemented that RO plant in their Gwalpari in National Institute of Solar Energy is there. Their production is very high, and nearby community is taking the water from the RO water from there.
From Gwalpari.
Yeah, Gwalpari. This National Institute of Solar Energy.
As such, I am interested in converting seawater. Is there anywhere they use solar energy?
Yes, sir. Yeah. For seawater, sir, like solar desalination, very conventional techniques. Solar single slope solar still, double slope solar still can be very useful. Like in per meter square of water, just you need to cover it. And some slope must be there. What happened? The solar radiations are coming through this glass cover, right? Shortwave radiations coming and falling on the surface of the water. At the bottom it is the blackened surface. The solar energy, the radiation, shortwave radiations coming through this, and it is impinging on the black surface over there. And the radiations converted into heat, the infrared radiation. And now slowly that water is heating, and because of the partial vapor pressure difference between the surface and just above the surface of the water, even though the temperature is not very high, not the 100 degrees temperature, because of the partial vapor pressure difference, it starts evaporate, and right, and it condenses on the this what is called glass cover, which is slope, and over here some collectors are there. The droplet when the water vapor comes in contact with this inner surface, and it gets condensed and slide over this and get collected in the channel, like in that way. So such kind of systems are very. My professor, Professor G.N. Tiwari, he has done a lot of work on the solar desalination, and he is a very famous person in the solar desalination. Many books he has written, and in fact the successfully and the commercial system he has designed many commercial system in India and the southern part of the India. In nearby Chennai, one project, a huge project, he has successfully commissioned that project, or DST project. Yes, for the seawater.
That's a slope testing we can use for the humidity in the air. Can we use that system, convert the water from?
Yes, sir. Yes. Humidity in the air that we can extract and condense. That we can also do. Yes, sir.
That can be same.
Yeah, one of my friend is there, the Hitesh Panchal. He has made one machine to extract the moisture from the environment and get condensate. he has patented recently. Yes, sir.
But I was also thinking the small portable PBT system. Can that be used for the house so that we can?
Yeah. Sir, it is there. Dehumidifier. That is a dehumidifier. But in dehumidifier, we need because we are taking the environmental air, that humid air, environmental humid air.
Right.
But that water you cannot drink directly because it has a lot of contamination, right, sir? So so first dehumidify the whatever the moisture contained in the environment, dehumidify, then filter. Yeah, again you have to purify. Yes.
I was thinking a small RO plant with a PBT system, which we showed for the.
Sir, actually, as we know, in PV, RO plant is possible based on the PVT system only. But in case of the PVT, you need it can be portable, it can be for the domestic purpose itself, but you need lot of power. For the generation of power, you need lot of space. Right, because of the dilute solar energy is dilute.
Thank you very much, Dr. Anil.
Thank you, thank you, sir. Thank you.
Enjoyed. I have only one question for our chairman. I don't know how he is going to give you the memento.
No, sir.
Next visit of Dr. Anil Kumar to Bahrain, we will keep it for that.
Thank you, sir.
As of now, we will send one certificate all the way from here, sir.
Yes, sir. That will be very useful for me. My
very informative. Appreciate it.
Right. Yeah. Thank you, sir. Thank you.
Anyone else? Anyone is having any question?
Good evening, sir. I'm from DTU. I've done my BTech in Polymer Science and Technology.
Okay.
I passed out last year. So now I'm studying at NYU, New York University. So I'm doing a master's in environmental science.
Okay, nice.
And I'm interning with the New York City Department of Parks and Recreation.
Okay.
So a lot of the times they would like to know, we have a lot of excess soil laying on the roof. We're doing a lot of urban green farming. So I would like to know if we have a lot of vacant space on any sort of rooftops. So could this be somehow incorporated into that system? Because we, as you know, in New York, it's a lot of skyscrapers and not a lot of free land. So is there any way we could utilize this on rooftops or any sort of, yes.
Yeah, in roof, if suppose you have the rooftop space, then definitely you can install the many kind of system. That depends on your usability, basically. What is your need based on that? But now, if you are in New York, and I do not think anything you would like to dry, everything is packed, available in the packed form, right? So basically, that. But you can install the solar water heating system. Hot water is needed around the year over there, right? And in fact, for the space heating also you can use the rooftop space for your purpose. Definitely, space heating is required over there around the year. I never been there, but I can guess only. So that and in fact, the transparent type collectors are there. That transparent collector you can use very effectively for the space heating. One thing, and another thing is for for water heating purpose you can use your space.
Thank you so much, sir. Thank you.
Thank you.
Any more questions?
Yes.
Sir, how can we utilize this system in petrochemical industry?
Petrochemical industry, sir, I have showed you one that is the maximum temperature in the petrochemical industry, maximum processing 200 degrees centigrade, I think. Not more than that requirement is 200 degrees centigrade. So that 200 degrees centigrade temperature you can easily achieve with the help of the any kind of if suppose the hot air, because you need some indirect heating surface over there, indirect heating, right? So the hot air can be, you can use the hot air, or the as well as the this hot water also you can use. So parabolic trough type collectors are sufficient for the 200 degree centigrade. Yeah, that we can do with the help of some heat exchangers, indirect heating.
Thank you. Thank you.
Sir, I have one question.
Yes,
sir,
sir.
now our Honorable Prime Minister, Mr. Narendra Modi, has created one. He has initiated this solar alliance with those
Yes, sir.
countries who are blessed with the bright sunlight. I think maximum part of the year. How we are contributing to that particular initiative, and how far we have reached?
Sir, actually, data says something almost 100 gigawatt we have already been achieved. But fact is that, sir, our dependency is on solar photovoltaics, because whatever the solar power generation from the solar energy that we have reached over there, reached that target, that is basically based on the solar photovoltaics. And for the solar photovoltaics, unfortunately, in India, we do not fabricating any types of solar cell. Just we are assembling in India, and totally our dependency on the China. So if someone is say we are energy secure, but our dependency is on other country itself.
Yeah.
Until unless we fabricate and completely fabricate in India itself, right? And in fact, sir, there is one solution. Like India has blessed with the ample solar energy, almost the 5.5 kilowatt per hour per meter per day. That much of solar radiations are available, and the Jodhpur and other like Jodhpur and some location in the Gujarat. So
Yes.
solar power generation through thermal route is very much feasible. We should plan in that way itself, instead of solar photovoltaics. And in fact, the 200 megawatt power plant has been commissioned in the in somewhere in the Gujarat and nearby Patan, right, sir?
Yeah.
But that is the photovoltaic base. Personally, I feel by that way, if suppose we are implementing the solar energy in the form of the solar photovoltaic route, that our dependency on the other country, some maintenance point of view, may not be successful, or if suppose it is successful, it is very bad. Good. But we have to rely on the solar thermal power generation with the help of the heliostatic type. That could be the success story. Now already the technology is already been what is called but somehow we can we have already achieved that that kind of technology in India itself. Basically, there was problem earlier. There was problem with the storage medium. So now that storage, the salt hydrates, which can store the energy at the high temperature, 700 degree temperature, has been already been developed in Indian CSIR lab. So, sir, that is only the possible solution. Otherwise, we may achieve the 150 gigawatt or the 200 gigawatt, just the installation of the PV system, solar plate, and it is not the indigenous, right, sir? And
Thank you, sir.
We are.
Thank you very
yes,
much for your
that's all. Yeah.
explanation. Thank you.
Thank you, sir.
May I request Engineer Arvind Gupta to express our vote of thanks, please?
Thank you, Dr. Anil, for giving us such a wonderful lecture. And my wish is that because, as you mentioned, that the solar energy can be used in the drying industry. India being a agriculture majority country, agricultural state. So even in the recent past, what we are seeing that during the when wheat crops is coming, and uh, uh, because of weather, the most of the crops is getting wet in the field itself. So if it is possible that this can be this solar energy can be utilized for the drying of the wheat crops in the controlled environment.
Yes, sir. For that,
Yeah. So I wish that you can write a project to DST or Ministry of Agriculture so that it can be implemented in the big way in the whole, not only the rice, pulses also. We are also deficit in the pulses. We are really depending on the other countries. So this will be very good for our country. So
definitely,
with
sir.
uh, that, once again, I thank you on the behalf of Institution of Engineers, Bahrain Chapter, and from the side of our chairman and respected members of the Bahrain.
Thank you.
Thank you very much, sir. Thank you very much, sir, for giving me this opportunity.
Thank you for giving your valuable time, sir. Thank you.